Hello. Today we're going to be covering kind of an extension of a topic we've done before. We're going to be solving equations with two equations and two unknowns. Solving two equations and two unknowns. All right, so what I want to start off is a review question, kind of the type of problem we did earlier in the semester. So let's say that we have these two equations. They're variables of x and y. So the first equation is 4 plus 2y equals 2. And our second equation is x minus 2y is equal to 6. Okay, so we have our variables x and y. And here this equation has y. So this is the type of thing we saw the first time, which was one of the equations contains only one of the variables. So the strategy, if you remember, is we would take this first equation and solve for y, and then we'll plug it into the other equation for y, and what we'll then have is an equation only with x's, and we can solve for x. So let's do that. So let's call this equation 1. Let's call this equation 2. So equation 1, 4 plus 2y is equal to 2. And what we're going to do is we're going to solve for 2y. We're going to solve for y. First, we're going to solve for 2y by subtracting 4 from both sides. So we get 2y is equal to negative 2. And then we'll solve for y by dividing both sides by 2. So we get y equals negative 1. And then what we're going to do is we're going to plug that into the second equation. And the second equation is x minus 2y equals 6. And what we're going to do, since we know that y is equal to negative 1, we're going to plug that in to solve for x. So minus x minus 2 times negative 1 equals 6. So we just plugged in negative 1 for y. We get x is x plus 2 equals 6. We get a double negative right there. Subtract 2 from both sides, and we get x is equal to 4. Okay, so we've solved for x equals 4 and y equals negative 1. So what you could do also is you can do a check here. So if you want to do a check, it's always good especially if you're kind of unsure if you did it correctly. So 4 plus 2, and what we're going to do is we're going to plug in this equation, y equals negative 1 and x equals 4. So this first equation, 2 times negative 1 equals 2. And if this is indeed the right number, then basically the left-hand side of the equation should be equal to the right-hand side of the equation. So we get 4, and then minus 2 equals 2, 2 equals 2. That one looks good. Now, let's check equation 2, so this is equation 1. Check equation 2 just to make sure. So if we plug in x equals 4, minus 2 times y equals negative 1 equals 6. So we get 4, double negative plus 2 equals 6, 6 equals 6. X equals 4, y equals negative 1 does indeed satisfy it. And also, if you want, you can write this as a coordinate, x equals 4, y equals negative 1. And again, we kind of briefly mentioned this, but there's kind of a graphical interpretation, which is that these are both linear equations, so they're both lines. If you were to graph them, their intersection of those two lines should occur at this point for negative 1. Okay, great. So now what we're going to do is we're going to do a more complex version of that same kind of problem. And what makes it more complex is basically if you see both variables in both equations. Okay, so if you look at this previous one that we saw, you notice that there was one of the equations that only had y, whereas this equation had x and y. So we're going to look at equations where both equations have both x and y. And that makes it a little bit more complicated, and that's basically the new thing that we're going to do in this lecture. So we have 2x plus y equals 4. That's going to be our first equation. And our second equation is going to be 2x minus 3y is equal to negative 4. So I don't know if you can hear that or not, but I'm in my basement, and so my furnace just kicked on, so hopefully that's not too loud. But again, you can see we have x and y in both equations. All right, so basically the strategy is the same. We're going to solve for one of the variables in one of the equations, so maybe I'll just put that as a strategy over here. So here's our strategy. So basically what we're going to do is we're going to solve equation 1 for y, but we're not going to be able to solve it for y in terms of a number. We're going to have to solve it in terms of x. So what that means is basically it's going to be we're just going to isolate y, really. We're not going to find a value for it, but we're going to have an equation for y in terms of x. And then what we're going to do is we're going to plug that in to equation 2. And when we plug in equation 2, that should eliminate the y, so then we can solve for x. And this time we should be able to solve a number for x. There goes my furnace. And then the third step is we'll plug it in to equation 1 and we'll solve for y. So that's an extra step. It's a little bit more complicated, but hopefully we'll do it and we'll see how it goes. All right, so let's do this first one. So usually when you look at these, the thing that you want to look for is you want to look for a variable that has the coefficient has basically a coefficient of 1, or you don't see a coefficient at all. Okay, so that's the one that usually you want to solve for. If it's there, sometimes it's not. So let's look at this equation. 2x plus y is equal to 4. So I'm going to subtract 2x. I'm going to get y equals 4 minus 2x. So there, what I've done is I've done step 1. So I'm going to call this equation 1 prime. Just to know it's like equation 1, but just rearranged a little bit. So what I'm going to do is I'm going to plug it into equation 2. So for equation 2, I have 2x minus 3y equals negative 4. And so what I'm going to do here is just like we did before. I'm going to use blue here. So this equation, instead of writing y, what we're going to plug in is we're going to plug in this expression right here. So we know y is equal to 4 minus 2x. So we're going to replace y with 4 minus 2x. Right there. So let's do it. 2x minus 3. And then I'm going to have this, here, I'll do it in blue. 4 minus 2x equals negative 4. I should have done this parentheses with a black marker. And then what we're going to do is we're going to distribute. Here, I got even another color here. The 3 gets distributed. So I get 2x minus 12, negative 3 times 4, and then negative 3 times 2x, I get a double negative, so I get plus. 3 times 2 is 6x equals negative 4. So I'm going to combine common terms. So 2x and 6x combines to be 8x minus 12 equals negative 4. I'm going to add 12 to both sides. So I get 8x is equal to 8. So I divide by 8. And I get x is equal to 1. Okay. So now I've solved for x, but also I need to solve for y now. So that's where this third step comes into play. Plug into 1 to solve for y. So actually what I'm going to do is I'm going to plug it into 1 prime. So 1 prime was y is equal to 4 minus 2x. And again, what I'm going to do here is x right here. I know that x is equal to 1, so I'm going to plug in x equals 1. So what I get is I get y equals 4 minus 2. And to be color consistent, I'm going to write this as a blue 1. There we go. So I get y equals 4 minus 2, y is equal to 2. And that would be a coordinate 1, comma 2. Okay? What you should also do is you can also always check this. So here, if I do x equals 1, 2 times 1 plus 2 is 2 plus 2 is 4. That's great. And then if I do this, 2 times 1 is 4, minus 3 times y is 6. Oh, wait, did I do this wrong? No, I'm sorry. 2 times 1 is 2, minus 3 times 2 is 6. So 2 minus 6 is negative 4. Okay, so both of those look good. All right. So I want to point out to you that in general, the best strategy is kind of what we did here, which is to solve for the variable that has only a single coefficient. But it really doesn't matter. There are lots of different ways you could do this. You can start from equation 1. You can start from equation 2. You can start by solving for x. You can start by solving for y. There really is not a major difference. I hope this furnace is not too distracting, but you know, I'm in my basement. So, oh, there we go. So what I want to show you is I want to show you the hard way. Okay, that should be 2 words, but that's fine. So this is hard. And basically is if it's done in a certain way, you might have to deal with fractions. So I just want to, if you get in your situation where maybe you don't pick the optimal strategy, or maybe the problem is not presented in a way that you can use kind of a simpler strategy, then you're just going to have to deal with fractions sometimes, and that's kind of what we're going to do here. Okay, so what I'm going to do is I'm going to start with equation 2, and I'm going to solve for y. Okay, so if you notice, there's a 3 in front of this y, so we're going to have fractions, and I'll show you that in a second. So if I have 2x minus 3y is equal to negative 4, to solve for y, I'm going to subtract the 2x from both sides. So I get negative 3y is equal to negative 2x minus 4. And apparently it's very cold in my house, so my furnace kicked back on. And then what I'm going to do is I'm going to divide both sides by negative 3. Okay, so I get y is equal to negative 2x over negative 3. One of the things, if you have this many terms in the numerator, you can divide each term in the numerator by the denominator. So that's what I'm going to do. Negative 2x over negative 3 plus negative 4 over negative 3. And I get y is equal to 2/3 x plus 4/3. So again, that's not like a really nice looking equation. Let's call that equation 2 prime. But, you know, sometimes that's how these things go. So what we're going to do is we're going to take that and we're going to plug it into equation 1. So I'm going to take equation 1, 2x plus y is equal to 4. And again, the strategy is we're going to take, instead of writing y right here, we're going to plug this in as 2/3 x plus 4/3, because we know that's what y is equal to. And essentially what that does is it eliminates y and we can solve for x. Okay, so we get 2x plus, and let's do parentheses again. Let's use blue for consistency. Equal to 4. So I get 2x plus 2/3 x plus 4/3 equals 4. And all I did there is I just got rid of the parentheses. I just wrote them as, you know, 2 separate terms. And so if you see something like this, the thing that you want to do here is you want to get rid of the denominators by multiplying each term by the least common denominator, which in this case is 3. That's the only denominator. So I'm going to multiply every term by 3, and that should get rid of my fractions here. So I'm going to do, here, let's do red. So I'm going to do 3 times 2x plus 3 times 2/3 x plus 3 times 4/3 equals 3 times 4. All right, so really what that does for us, which is kind of nice, is it gets rid of our denominators here. So 3 over 3, 3 over 3. So those cancel out. So what we're left with is 3 times 2x is 6x plus 2x plus 4 equals 3 times 4 is 12. All right. So if you're looking at this and you're saying that seems kind of wild, this is the hard way. So, but sometimes that happens. You might have to do things the hard way. So we have combined common terms, 8x plus 4 equals 12. I just thought, yeah, the hard way is doing this lecture in my basement on a workbench, and that's what I'm doing. So here we go. 12 times 4 is 8, divided by 8. X equals 1. Great. Okay, so again, once I have x equals 1, I'm going to plug it back into this equation. So I'm going to plug it into 2 prime, equation 2 prime. So that equation is y equals 2/3 x plus 4/3. So y equals 2/3 times 1. All right, I think I'm doing a good job being consistent with the colors I'm choosing, which is what I want. So 2/3 plus 4/3. So adding fractions, they have a common denominator, so you can just add the numerators, keep the common denominator. So this is 6 over 3. Y equals 2, which is the same answer we got before, 1 comma 2. X equals 1, y equals 2. Again, different paths get you the same place. These are the same 2 lines. If you graph them, they would still intersect there. They're just, sometimes you can take an easier path. Sometimes it takes a harder path. Sometimes you'll be forced to take this harder path. So I just wanted to show you that to prepare you for something like that. Okay. All right, so what I'm going to do is I'm going to give you one to try for yourself. So here we have, so try it for real. So what you could do is you could just sort of keep watching the video, but I think what you should try to do is actually try to do this. I meant to say in the beginning of this lecture that you should be taking notes. Even though this is just a video, you think I could write it again. I think the act of taking notes actually will help you stay engaged with the video, and also I think will kind of help you remember it better. Okay, so 5x minus 4y equals 9. X minus 2y equals -3. So again, what we want you to do, solve for x and y, solve for one of the variables, plug it into the other equation. So why don't you try that right now? You could pause it, try to do it yourself. I can kind of talk you through some things here. If you don't want to hear me talking my way through this, you could just fast forward through this until I start writing. But basically, I think one of the things I would do here is, let's call this equation 1, equation 2, is I would solve this equation for x, because there's no coefficient there, so that means that we're not going to deal with fractions if we do that. So if well, you could deal with fractions anyway, but let's say solve this equation for x in terms of y, And then once you have that equation, plug it in for x here. And then you should have an equation only with y's. And then you solve for y. And then once you have the number for y, plug it back into 2 to solve for x. Okay. So pause it and try to do that. If you feel like this is really easy, you could do it the harder way. And the harder way, in my opinion, would be to use equation 1 and to solve equation 1 for x in terms of y. This is where you get a fraction. And then plug that in equation 2 for x, and you should have an equation only with y's and numbers. You should be able to solve for y, a number for y, and then plug that back into equation 1 to solve for x. All right. So hopefully you did that. So let's do the easy way. All right, so the easy way is to solve for equation 2. So I'm going to do x minus 2y is equal to negative 3, and I'm going to solve for x by adding 2y to both sides. So I get x is equal to negative 3 plus 2y. So let's call this 2 prime, equation 2 prime. And then what I'm going to do is I'm going to take equation 1, and I'm going to plug that in. So I'm going to get 5x minus 4y equals 9. And again, I'm using blue to represent a plug-in. So I know x is equal to negative 3 plus 2y. So I'm going to replace x in this equation with negative 3 plus 2y. So I get 5 negative 3 plus 2y minus 4y equals 9. And I think I used red for distribution, so that's what I'm going to do now. So that 5 gets distributed to each of those terms. And again, you see here, I don't have any more x's because I essentially eliminated them. So I get 5 times negative 3 is negative 15 plus 10y minus 4y is equal to 9. Then I combine common terms. 10y minus 4y is 6y, so minus 15 plus 6y is equal to 9. Plus 15 plus 15. So 6y is equal to 24. For some reason, I looked at that and I thought 25, but that's not right. So 6 divided by 6. So I get y is equal to 4. So I get y equal to 4. And then what I have to do is I have to plug it back into the other equation. So I'm going to plug it into 2 prime. Plug into 2 prime. So I'm going to plug into 2 prime. X is equal to negative 3 plus 2y. And here, y is equal to 4. So I'm going to plug in 4. So again, one of the ideas about algebra, if you feel really comfortable about algebra, is this idea that numbers and expressions are basically the same thing. So if you can plug in a number, you can plug in an expression. It's the same idea. Plus 2 times 4. So x equals negative 3 plus 8. X is equal to 5. So we get our answer. X equals 5. Y equals 4. There we go. All right. So we could look at this again. Let's just plug some stuff in. So 5 times 5 is 25. Minus 4 times 4 is 16. 25 minus 16 is 9. That's good. 5 minus 2 times 4. So 5 minus 8 is negative 3. And negative 3 equals negative 3. So that also looks good. All right. Did you try it the hard way? Let's try to do this the hard way. And we'll see if you tried the hard way to try to challenge yourself. Or maybe you feel like you didn't try the hard way, but you want to pause the video right now and try the hard way. All right, so let's try the harder way. So the hard way is to start with equation 1, 5x minus 4y equals 9, and try to solve for x or y over here. So I'm going to solve for x. So I get plus 4 on both sides, plus 4y on both sides. So I get 5x is equal to 9 plus 4y. And divide both sides by 5x. And then I'm going to divide each term in the numerator by the denominator. So 9/5 plus 4/5 y. I'll just mention this because I see this a lot. If this were reversed, if you had the 5 in the numerator and then you had, multiple terms in the denominator, you can't. This doesn't work in reverse. You can't divide each. You can't divide the numerator. You can't divide the numerator by each individual term of the denominator. Sometimes people try to do that, but it only works by dividing each term of the numerator by the denominator. All right, hopefully that made sense to you. So we have this equation. Let's call this 1 prime. It's kind of ugly. It has fractions. But what we're going to do is we're going to plug that into equation 2. So we get equation 2 is x minus 2y equals negative 3. And what we're going to do is for x right here, we're going to plug in 9/5 plus 4/5 y, right? Because that's what x is equal to according to equation 1 prime. So I'm going to get, I feel proud of myself that I've not messed up the colors I've chosen for this substitution. So I get 9/5 plus 4/5 y minus 2y is equal to negative 3. And what I'm going to do is I'm going to multiply every term by the least common denominator, which in this case is 5. So I'm going to get rid of that 5. So here. So I'm going to multiply a 5 here, and then another 5, another 5, and another 5. 5 times every term, so 9/5 plus 4/5 y minus plus negative 2y equals 5 times negative 3. All right, and again, what that does is the denominators cancel. There we go, no denominators. All right, I feel like I'm talking to myself. All right, so 9 plus 4y is equal to negative, not equal to, minus 10 equals minus 15. No, minus 10y. All right, there's another problem is no one's here to correct my errors, so we'll see if any errors come up. All right, 6y is equal to minus 15. So subtract 9 from both sides. So minus 6y is equal to minus 24. Okay, great. Divide by negative 6. Y is equal to 4. Okay, so now we have y equals 4. We have to plug that into one of the other equations. So let's plug it back into 1 prime. So x equals 9/5 plus 4/5 y. And again, proud of myself. Substitution color is blue. All right, so x equals 9/5 plus 4/5 times 4. So this becomes 9/5 plus 16/5. They have a common denominator, so you can add the numerators, keep the common denominator. So this is 25 over 5, and that gives us x equals 5. There we go. X equals 5, y equals 4. That is the same answer we got before, but done the hard way. Okay, so hopefully you feel pretty good about that. We're at the 28-minute mark. So I want to show you one other variation. So I think on the homework assignment that I assigned for this, there are 10 questions, and the first 6 are kind of like the ones I showed you there. You can choose to do them the hard way, the easy way, whatever one. I think they all have the possibility of doing it an easy way. But when I show you, there are some, the last couple of them are a different type, and they're solving for x or y in terms of a symbolic variable. So sometimes you'll see this with symbolic equations. You might have to solve for a quantity in terms of another quantity. So that's what I want to show you now. So solve for x and y in terms of the variable a. So let's look at what these kind of problems would look like. They would look like this. 3x plus 2y is equal to 4a, and 2x plus y is equal to a. So again, it's really the same exact procedure, but now it's not just numbers. You have to carry around the answer a, and your answers for x and y should be in terms of a. So 2a, 5a, 1/2 a, 6a plus 5. I don't know, whatever. But they would be solved in terms of a. Okay, so this is equation 1 and equation 2. So again, what we're going to do is we're going to solve for one equation. I'm going to solve equation 2 in terms of y, because there's no coefficient there, and that's kind of the easier way. And you should, if you can kind of spot that, you should do it that way. So I'm going to solve for y by subtracting 2x. So y equals a minus 2x. All right, so let's call that 2 prime. All right, and what you want to treat a is you just want to treat a like a number, basically. So it's just a number, and if you get an answer in terms of a, that's as good as it being some value. So we're going to plug in to equation 1. So equation 1 is 3x plus 2y equals 4a. And right here, for y, what we're going to plug in for y is the expression a minus 2x. And again, that's because the value for y is equal to a minus 2x, so we should be able to replace it in there. So we get 3x plus 2 times, I almost messed up there, but I'm using blue for substitutions, a minus 2x. There we go. All right, so if I make a mistake, just tell me, write a comment or something, and then I'm not redoing this video, but I'll add some sort of note to say that I made a mistake. 2a minus 4x is equal to 4a. Okay, so a combined comment, there's 3x minus 4x is negative 1x plus 2a equals 4a. Subtract 2a. So negative 1x is equal to 2a. So divide by negative 1. So we get x is equal to negative 2a. Okay? So if you divide by a negative number, that's the same as multiplying by a negative number. So x equals, ooh, I'm sorry. I think I went off camera there. I should make a mark here. Okay, so then what I'm going to do is I'm going to plug this in to the other equation. So I'm going to plug in into equation 2 prime. So y is equal to a minus 2x. And here we know that x is equal to negative 2a. So we get is y is equal to a minus 2 times negative 2a. So we get y is equal to a plus 4a. Y is equal to 5a. So then we have a value for x and y, negative 2a and 5a. So both x and y have been solved in terms of a, and that's basically what we're looking for here. So what I want to show you is kind of where you might see this later on. So I think a lot of you maybe already know that I'm a physics professor. So this would be the type of algebra that you would see. Generally, I think I do this sort of thing in introductory physics. For people that are like not too algebra savvy, it kind of seems like black magic to them. But let's say you had a situation like this. This is just an example. I'm not going to put this on an exam or anything like that. This is kind of something more difficult. But this would be the kind of symbolic algebra that you might see. This is kind of a classic one. So let's say that you had like a big thing, a big mass, A, and it's traveling at some velocity. And then there's some smaller mass B that's at rest. So this is velocity is 0. And then they collide. And then what happens is that big A slows down a little bit. So it has some final velocity, VA2. And then VB, gets shot out, VB2. All right, so this is a classic example. Let's say this would be like an elastic equation. What you would do is you would set up a series of equations for conservation of momentum. So for conservation of momentum, the equation would look something like this. MA, VA1, and then there's no momentum initially for this one. And then the final momentum would be momentum of each of these. So MA, VA2 plus MB, VB2. Okay, and then you would see something like if it's elastic, you would have a conservation of mechanical energy, kinetic energy. So the equation for that would be the initial kinetic energy, MA VA1 squared, and then the final kinetic energy is 1/2 MA VA2 squared plus 1/2 MB VB2 squared. And so this may not really look like it. It looks like it has a bunch of variables. But the way you would treat this is you would treat it like a given/known would be like you set this up so that you know what the masses are. You know how big the things are.